Okay, now I think we are good to go. Hello everyone, welcome to my channel, and in today's video we will be solving today's Leetcode daily problem. And yeah, this is the walkthrough of the same. Like, I just need to check if the audio is coming up. Okay, now I think we are good to go. Hello everyone, welcome to my channel. Yeah, this is cool. Now, without any further ado, we will jump in to solve this problem. Before that, I want to tell you three things. First, this problem I haven't seen before. This is my first attempt. And second, it is a live attempt. So I don't know about what inside the problem statement. So there is a framework on how we proceed with. And the third point is about the framework. So the framework is we read the problem and we build a logic which is in the terms of algorithm. So the logic to solve this problem will be the algorithm. And then we jump into the constraints and then see what data structures we can use to solve this problem. And then we solve it and then check if it passes. Then we go ahead and code everything what we have planned. And then we check if it is a successful submission or not. So this is the entire flow. I hope you guys will be with me and we will solve this one. Right. Okay, so let me just go ahead to this guy, my iPad. Yeah, my iPad notes. Here we have this today's problem. I have already taken a screenshot, and trust me guys, I haven't even read the title yet. Okay, so without any further ado, I'll just go ahead and solve this. Right, so first thing, reading the problem statement. The problem says find the unique binary string. Okay, let me use another color. Yeah, unique binary string. Okay, binary string, and which is unique. Okay, given an array of strings nums containing n unique binary strings. So there is an array given nums which is of strings. So yeah, this is of strings, right? And it has n unique strings. Binary strings, okay? And they have a length of n. Return a binary string of length n that does not appear in nums. If there are multiple answers, you may return any of them. String of length n. So we have to return a binary string, right? A binary string of size n that does not appear in nums. So basically, nums is an array which has n unique strings, and you have to give one more binary string which does not appear in nums. Right? That's what I figure out from this. If there are multiple answers, obviously there can be multiple answers. We can print any one of them. So what my understanding says is that this contains n strings, right? And all of them have size n, right? So since it's a binary string, at each place you have two options of zeros and ones, and you are given n strings, right? So there could be like 2 to the power n possibilities, right? And you are given n strings, so it is mostly going to be easy because there are only n strings which are in the num, and we have 2 to the power n other strings, out of which we have to choose the one which is not in this particular thing, right? Which is not in this particular nums array. That's what I figure out. Let's take look at the example case cases. So this is the nums, and here we have two strings. So the n is 2 here, and we have got 0 1, and we have got 1 and 0, right? So again, it is a two place thing. So we have 2 to the power 2 4 options, right? Out of which 2 are here. We have to give one more. So in this case, they have just returned 1 1, which makes sense because it is not in the given. It is not in the given nums array. It is a separate one, so it's fine. So 11 does not appear in nums. 0 0 would also be correct. That's true because another option which we got is, so this is the first string, second string, third string. This is the fourth string, right? And then we have this. Take this one. So here we have, this is the first, second, third, and there was one more option which is left. 1 0. Makes sense. And for this test case, it is also pretty much straightforward that, right, so out of all these possibilities, I can simply say like 0 0 0 is not there. This is also not there, this is also not there, right? So we can return any of them. So this makes it very simple, to be honest. The constraint's length is here. We will jump to the constraint, but the what basic algorithm which I built from here, like how can I solve it? So the basic algorithm would be like this. Out of 2 to the power n strings, return 1 which is not there, correct? Why is it called nums? I don't get it, because nums means like numbers, but it is a binary string, right? Okay, so maybe maybe I'm sensing like they might be indicating to the bitwise operations, because you see nums means like numbers, and in the end, if you see the binary strings, it will represent a number, and n is pretty much small here. We'll jump into the constraints later on. So let's see this, right? So the basic algorithm approach will be this, uh, like this, basically 2 to the power n strings. The common root for solution will be this, because see here, so this is the array, and we all know that we have got 2 options here, zeros and ones, right? So we have to iterate in all the 2 to the power 16. Let's not jump to the constraint. 2 to the power n strings, and check if they are in nums, right? We have to check this. If yes, and if no. If yes, then return it. Sorry, not return it. If yes, then basically continue the search. If no, then return the result. This is, I don't think it is difficult, because when we iterate to 2 to the power n strings one by one, what we are getting is, so we will iterate with the first string, we will iterate the second string, third, fourth, all the way up to n, right? 2 to the power n. But since there are only n elements in this, right? So this is very easy. This is very easy because when we do n plus 1 iterations, when we reach to n plus 1 strings like this will be an end. This will be an end because at the worst case, out of these n plus 1 strings, n are there in the nums array, and the n plus 1th string is our answer, right? So we don't need to actually go to all the 2 to the power n computations. So we need to generate n plus 1 strings at the worst, and there is sure short like one out of them is our answer. I think everyone gets my point, because this is the thing. And checking if they are in nums, it's gonna be quite difficult, to be honest, but we can work around. We can make the algorithm better. Because it is an array of strings, so you can store the strings in vector, and you can do vector dot find, because that's fine, because this is just simply like order and log n operation, right? N log n into n, I would say, because the strings have a length of n as well. But that can be reduced, because if we convert these numbers to, let's say, binary numbers, binary numbers to decimal numbers, that will do the job, right? So this is the entire gist of it. This is the algorithm basically, right? I think it's clear. Now let's jump to the constraints. And now in this step, this is step 2. Now we are incorporating the constraints into our algorithm. And here we need to make a decision with how we need to change our approach, how we need to modify our approach to solve this, right? And then we write, in the third step, we'll write the code logic. Okay. So the n value of n is 16, right? So 2 to the power 16 strings will be there, but we don't need to go to 2 to the power 16 strings at once. I hope you all get my point, right? So the length of the string could be n only, which is of the order 16, right? So we need to generate 17 strings at the worst case. So this is the worst case scenario we are looking at. So we will generate 17 strings, right? And we will check. The first operation is checking. The only operation which we got is to check them, and checking will take for each of the string 17 times order of n square log n if we do vector of strings, and it will be 17 into order of n log n if we do bitwise. This is the case. So this boils down to 17 square, 17 cube, which is in fact good to know. Let's say it's 20 cube. So it's like 200 into the power 3, 800 into the power 3, which is well beyond, well inside the limit of the acceptance. This is again 17 square, right? I get this. So we have two possible approaches to select from. The first one. Now we are moving to the third stage, which is logic. So this was the first stage statement. This was the second stage. This is the third stage. Quick summary, guys. So, right. So the problem statement says that there are n strings and they're in the array nums. All of them are binary unique strings. What we have to do is we have to return another binary string which has the same size of length n, and that does not appear in nums, which is not in nums, which is a unique string out of that, and we have to just return it. and they say if there are multiple such answers, you can return any of them. Correct. Now here is the algorithm which we have built. The algorithm says, so algorithm which is basically, we thought that there are 2 to the power n possible strings, because for a length, for a string of length n with the binary values, there are exactly 2 possibilities at each spot, so it accumulates to 2 to the power n. Then we have to check. So now what turns out, like, the basic algorithm will be like this: there are 2 to the power n strings, you check each one of them if they lie in norms or not, then you say if yes, then continue, look for another one. If they don't lie, then you just go to the no and you return the string which you found. Correct. And then you have this particular thing here. So this particular thing is the core thing. So here we realized that we don't need to check all 2 to the power n strings, because when we create n plus 1 strings in our journey, one of them is sure shot gonna be the unique one, because we generated n plus 1 unique strings of length n. In the worst case, n out of them are already in norms, so we are good with the other one, right? The one which is left. So n plus 1 is pretty much sufficient. On this I have did this constraint analyzation, and I found there are 2 code logics which we can go with. Now I'll talk you about 2 ways by which we can solve it. So now we are moving to the third step, which is code logic. There are 2 possibilities. First is use vector of strings, right? The second possibility is to use bitwise operations. Let me just explain you a bit about each one of them. So we have to generate n plus 1 strings. So in this approach, we have nums vector which has all strings. To be honest, all n strings in it. Correct. And then we have we are going to generate it. So we will start our recursive algorithm with this. The first spot is 0. Then for other spot we got 2 options, 0 and 1. Then we got 2 options for the third spot, all the way up to when we make a string of length n. Check, right? And then we do for 1 as well. I think this will be enough in the first place. Right, so here we have these 2 possibilities, and then we are good to go. And we check, and then once we spot it, we go ahead and when we get exited of that recursive. Right, we have to make an exit, which we need to think. Now this is the basic approach. We already talked about time complexity. It is 17 to the power cube, which is quite relevant, which is quite noticeable. Now if I go to the bitwise way, so here what I have to do is to norms, which is a strings array. I have to convert it to vals, which is a bit values, right? This is the thing. And then if we go ahead, how we are going to solve it? We start with a number 0 and we look at n bits of it. This basically, so this is like 16th bit. Right. So for each bit we will basically do the same thing which we did here. Assign it 0 and then move, then assign it 1, then check. the next step like this. So the only difference which is here in this step is that checking is easier. Here it is just order 17 square because of the numerical values which we can simply look into it. Here it is n log n, I know, but it is also very much okay for the given size of the given constraints, right? So I would like to go with this approach because honestly it is not needed to complicate it unless asked in a real interview to use this, because this is a better solution. I know that it will incorporate more test cases, but for the time being, for the sake of the medium simplicity of this problem, I'll go with this one. Now let's talk about every bit and pieces needed to create this code. Okay, so the data structure is given to us, right? This is a vector of strings. What data structures we need for us? We need a recursive stack, right, which is generating these numbers, and then we need to do two things, like yeah. So the recursive function which we have, obviously this is a level by level recursive. So here will be the current level. We are at the 0th place at this beginning. This will go all the way up to n. Then we have the string which we have, or the character which we have. Temp string will do something like 0, 1, right? And then we have, I think this is it. Okay, we need to go like this only. This is fine. What will this return? There are two options. Since we need a string output, so we need to return that result string, which is making it possible. So it should return the string. There are two options of size m, right? There are two options. First option, to return whether it's unique or not. So I'll call this a boolean, which will be, and it will return the answer string, right? Now how to frame this in a recursive manner, that is the challenge. So let's write the recursive code here. I'll use another color, maybe red. So here the base case of recursion will be, okay, the base case of recursion will be if L is equal to n. Obviously we need n here to be used as like the size which we need, and that is just passing out the things. We might also need nums, and that is another thing. In this case we have to make a check. If check is yes, if check is no, in that case, if it is unique, so this is basically unique or not. If it is unique, we have to return a response like this. It will be a yes, and it will be the string answer which is there, string yes. If it is no, in that case we return no and string yes. This is the end result of this particular base case, right? And what we do here is we go with s plus 0 and L plus 1 state, and we go to S plus 1, L plus 1 state. Obviously between here we will be doing this S minus the last one, the last character which we appended, we will just subtract it, and here we go like this. The thing is, what will be the return statement at this particular step? So we keep going. Here we will hit this thing, right? Correct. So these are the two states which we are looking at particular step. What will we return here to get that string value? The string size here is basically 0 or 1. It's not n at a particular level. Or you know what? Instead of returning things, what we can do otherwise is to use a global variable which is answer, right? And here we assign it. We assign if it's a yes check, we assign that as answer. So in that case, we no need to worry about what we have to return here. We reach this state and we return the answer. We save it to the answer, and obviously we have to stop. Here we have to stop, right? So here I will add a base case which says if answer is set, then return. Don't go any step further. So yeah, this makes it. I'll write the code logic here in a better way. So we have the main function, basically which will call everything. So we will start with a recursive function which needs level which we are at, and which needs the size of the string, which also needs a string which we are maintaining. So in the beginning we'll start with a level which is -1, and we will have an empty string, and then will be passed as it is. We have a answer variable over here which is currently assigned to this. So base case 1 is uh, answer dot size is equal to n. Then we have to just return from the recursive stack, and here we will just return our answer. Second base case is this: if level equals to n, then we do the check for this particular string, and then what we do is basically we, if it's a yes, if it's a no, if it's a yes, set the answer to that string, just this. If it's a no, we have to simply return, right? And then the cases here, so here we will, this is the recursive approach. Here we will just add a 0, level plus 1, then we do -0, and here we do s plus 1 and go to the next level. That's fine, right? We go to the next level. This is the code logic, and we are with the code, I guess. Now I have to just translate it into the C++ code which is there in the Leetcode pattern. Right. Let's move ahead to the coding section. I'll quickly check if we have any visitor with us. So C++ code, which is there in the Leetcode pattern. Right. Let's okay. Let's go ahead and code it up. I am logged in, but this is not a very difficult thing, right? Let's set to this. We have two things only. We'll apply the values. I'll be passing left temporary string. I'll be passing nums. I'll be passing answer. I'll be answer. The code will just create a recursive function which returns the answer. It is it is node s. We need to add. Okay, this string will be. We have one string only, so it's fine. We pass it by location of this thing, and then we have turn of string, and this one once before that we have user, and then we have string, which is our answer. Sorry, this is answer. Right. So there is the first base case. Base case, which was I got check function here, just taking the belongs and s here, right? Instead of -1, we will keep it 0th level. Right. I think we're good to go. Now we have two options here. S dot roadmap, 0 plus, then we do this thing. And then we have to hop from the back. I hope this is the syntax. Maybe just connect. Let's check. We have a cursor. Uh, Let me copy this thing and can I move it here? Push down one, right? And here we need to return now. Here we need to return nothing. We don't need to return anything. This is more or less the logic, right? Let me write the check function here, which returns a string which sets up answer as well. So for that I need these guys. It returns the string. So what we need to do is get equals to nothing. You need to do a find, vector find thing. That will automatically do the job. Okay? So I need to check what is the find thing. I need to check the syntax of find, but find much I'm not aware of. I'm checking it in my iPad. Let me see. To find. Yeah, it is just find. Okay. It is in the algorithm library and it is just find. Okay, and we need to pass the iterators and we have given distance which is 0 1 2, right? This is auto IT. What does it returns here is the find first last value. It returns an iterator which if we subtract with we begin we get the value, right? Okay, so we can auto which is right find one start again one start and this is scope where we find the string which is s here. Yeah, I think we are good to go with this. And then we have to do this return widget minus once again. If we find it, we get it as this. If we cannot find it, then we get it an n iterator, right? So if this is equal to n, if this is not equal to n, sorry, I'm returning that. I didn't mean to return anything. So if id is not equal to nums and 8, we have got the answer, right? So this will be answer to the temporary string which we have. That's all we need to do. id, if this iterator is not at the end of the vector, it means that we have find it somewhere, and this is the answer. Right, we are good to go with this. I hope so. We are good to go. This will take care of not going into like 2 to the power 16, 17 cases. 2 to the power 16 is somewhat in the order of, let's say, 2 to the power 18, which is 2 to the power 3 to the power 6. Or 2 to the power 3 is 8, which I take as 10. Even that was not a big deal for this. I think it must have a hard version. There can be a hard version of this. Okay, anyways, let's check this if it runs successfully or not. So we need to first pass string s, then we need to pass. We need to pass the answer here. Okay, it is popped back. Hopefully. Right. Sorry, not. Let me check what's the problem here. This is the string s here. This is n, this is nums, this is answer. Parsing argument to parameter s here. Okay, got it. So non-const L value reference to a string, so cannot be. Oh, I cannot get this, to be honest. Cannot bind a value unrelated to type s. Maybe because of this, since we're using we're passing it by reference, so we may need a constant variable, not just a temporary variable. So I can keep it s over here, and it is not accept. No, I don't think so. So we need to see if it is working or not. It works, but the output is still not there. So what was the problem here? It went with 0 to the next level, 0, 0 should be the answer. Right, so the level will be, I pushed back 0, the level will become level plus 1, which is definitely 0 plus 1 is 1, right? In the next step, when we append 1 or 0, the level will become 1. The answer size is still 0, right? The level will become 2 now, so we need a check. We make a check. If id is equal to nums end, then we need to append it once. That's a very dumb mistake, to be honest. I will work on it. Okay, so we get some more issues here. This is fine. This was something here happened which is different. How we went to this state at the first place, because this runs only if the level is n. That's happened in my opinion. Was first 0 and then we appended. Then we went ahead to the next level, which was 0, 0 for the time being, right? Okay, after this step, this very step, we need to pop back. I was skeptical about this game. It was in my mind, but you guys should notice this, because if we go to the one level ahead, we need to undo things which we have done already. So what had happened in this case is basically we appended 1 over there, right? At some step we appended 1, and after that we did not remove this, and we just went on with the next traces, which is like, which exactly is basically working on this particular thing. And this thing, we'll change it to 1, we'll change it to 0. So that's what happened here. Now if I run, I think it will be fine with all the test cases passing it. See? Yeah, I think it is good. Now I'm really sure it will pass it. Let's see if it does. Otherwise we need to debug and this video will get longer. There we go. It is a good solution, but I won't say the best solution, because we all know that the best solution is somewhere here. This is the logic which we just coded, and this is the best solution, the second one, where we use bitwise operators. This is n square, this is actually n cube, right? Cool. So guys, I think we are done with the problem of the day. And quick thing, the today's problem will be there in 1 hour 53 minutes, so I'll be solving that as well, so you can check my channel again if you have time. That's all. See you next time.